Давайте начнем, наверное, время.
Well, let's get started. I suggest that we do not waste time. If we have more participants, we certainly will be very glad to greet them. Well, good afternoon, dear colleagues. So we have run out of time. And I suggest that we get started. Our session was on the international cooperation to fight spread of feral herd infections. Well, dear colleagues, you certainly do know that infections have no borders. And first of all, that regards to feral herd infections such as plague and other dangerous infections, tularemia, fever, Crimea hemorrhagical fever, and so on. So this question is very relevant, and I would like to pass the floor to our first speaker, director of the Scientific Research Institute of Irkutsk and the Far East region, Balakhonov Sergei. Good afternoon. Good afternoon, dear participants, dear colleagues. While my presentation is being loaded, I would like to say thank you for the invitation at such important conference, and will say a few words that cooperation to provide epidemiological safety and well-being between Russia and Mongolia have a very rich history. And it marks by a number of events. I certainly would not stop on all of them, but certainly I have to mention that this year, next slide please. This year we celebrate the 90th anniversary of Russian and Mongolian cooperation on prevention of plague. In 1931, the first laboratory on long-term cooperation between the USSR and Mongolia was established in the city of Ulagbaatar and transferred to the Ministry of Health of Mongolia. And at the same time, a large team of Russian plague experts started to work in Mongolia, headed by Mr. Berlin. And they started to provide trainings to Mongolian doctors in order to provide sufficient monitoring in areas infected with plague. They started to train new specialists, and this work has been continuous for 90 years, including the World War II. There was a short break in 1991 that ended in 2016, and unfortunately that break led obstacles to provide epidemiological safety that I'm going to talk about. Next slide, please. So what is the importance of this international cooperation to provide epidemiological safety between Russia and Mongolia? Well, on this slide, we see that we actually have a joint issue we have to address together. I'm talking about plague areas in Mongolia that, as you see, are quite frequent. In total, there are 49 plague sites that are located in various geographical sites. And moreover, we understand that we have a very long border between Russia and Mongolia. There are lots of transition points. And besides, there is migration of animals in between the countries, as well as lack of visa requirements. Besides, we have close cultural ties with this between each other, which lead to higher risks in plague distribution. As you see, the north parts highlights the plague areas in Russia. One is located near Lake Baikal, and on the left we see two more sites in the mountain regions that actually cause lots of problems to our states in Russia. In Central Asiatic zone. Next slide, please. So, as for development of the joint activities in Mongolia, it follows the following scheme. At that time, certainly a number of Soviet experts were working in Mongolia. There was a center of nosology infections, and it has 14 branches in areas with frequent outbreaks of plague. But given the intensity and the high distribution of plague in the country, certainly it always needs more qualified personnel. Mongolia needs support that it gets from Russia. In 30 years, we have prepared statistics that shows outbreaks of plagues in 30 years, in the last 30 years, and we see that in 13 districts, and overall there are 21 districts or counties in Mongolia, they count for 60% of Mongolian territory, and every year they have complications with plague. As for dynamics of prevalence of plague, looks as follows. Even though starting from the year of 2000 there have been seen some stabilization, at least it is treated successfully. So the incidence is limited by very few cases. Still, we see that mortality rate is more than 42%, which means that this is a very severe problem, as we understand that if infection goes to the next level of spread, it leads to other mechanisms of dissemination that complicates the measures that have to be taken. In 2012, for the first time on the border with Russia, we have detected the virus on the border of Russia and Mongolia, and we detected high virulent strain of plaque microbe, which was absolutely surprising to us because previously we had never found a strain like that on the territory of both Russia and Mongolia. So we understood that the potential of this outbreak could be very high, and there was a risk to infecting other people, and that was proved in 2014, 15, and 17. There were 3 cases of plague in Russia among local people after they went hunting illegally, and they got infection through a contact with animals. Each case was detected quite fast, patients were isolated and a number of measures were taken in order to prevent the infection into entrepreneur's phase. Can we go back on the previous slide? On this slide, I also want to draw your attention to the fact that before 1990, this territory was under very strict monitoring, and we isolated more than 50 strains of plague. But they all were non-virulent strains. Never before 2012, we did not get high virulent strains. Therefore, together with the Mongolian Ministry of Health, we started to develop a program on reducing plague spread that was included in the decree of the Russian government by 2016, and the certain mechanism was launched in order to minimize the said risks. The main directions of our activities are shown on slide. So the number one goal was to prevent a distribution or spread of plague in the Russian Federation. So what will we going to do to increase our prevention measures, high level of anti-epidemic readiness both in Russia and Mongolia, irradiation of plague sites, materials and financial support to Mongolia, and improvement of international cooperations to reduce the risks of plague infection. So next slide, which I really want to show you, shows our joint cooperation. So first of all, we did joint expeditions to monitor plague sites, and within 3 years we carried out a very thorough work. Joined teams of experts from Russia and Mongolia were working on the border between Mongolia and Russia, carrying out a number of actions to evaluate properly the current situation. In 2020, unfortunately, that work had to be stopped due to the outbreak of COVID-19, as the border between Mongolia and Russia was officially closed for the set period during lockdown. Here you see areas where we conducted our studies. So we worked along the Russian border, and the distance of our work covered 100 kilometers. So you see the number of sectors that were evaluated in 2020. Here you can see data provided by our Mongolian colleagues of work that they did on their own. As for methodology, we collected field material, including remains of dead animals that died of plague, from plague. So we did visual monitoring, collected dead bodies of animals. So our experts would monitor a site on car by car, and they would kill infected animals and would collect some parasites. As during the studies, we used all the available tools. The set results we would carry on the electronic cards and made geographical positioning in order to understand the release of the plague microbe when we had positive PCR and immunochromatography tests. As for lab tests, we did it as follows. All field materials that had been collected would undergo PCR test and immunochromatographical tests. When we got positive results, they would would undergo bacteriological test, and depending on the result, we would take the appropriate actions. As for efficacy of those express tests, and the random bacteriological test was more than 90%. So this is a very good solution for field screening. First year we worked in camps, and next year we used the designated lab that has been shown on this conference previously. Overall, within 4 years, within the 4 years of monitoring, we isolated 99 strains of strain of high virulent subtype that led to outbreak in Mongolia and Russia. All those strains, apart from one, was obtained from gray ferrets. And I should say that the sites of the strains were located in the area of 1,963 square kilometers along the border with the Russian Federation. And they were very close to the border with Kazakhstan and China. The main results of work carried out in 2018-2020 was that there is a circulation of a significant pathogen of plague. It has been detected that in the studied area there is intensive plague spread that is led by Yersinia pestis microbe, and it has been registered in the mountain of Siligin in the southern side, starting from Ulan-Daba to Dorlen-Daba summit. So all these sites were at the height of 22 to 2,800 meters above the sea levels. As for epidemiological situation, the situation was not easy. It was tight. We witnessed group outbreaks in Mongolia with generated shape of plague with 100% of mortality, almost 100%. Therefore, contamination was due to hunting or consumption of raw meat or internal organs that are believed to be medicine in Mongolia. In 2019, we also observed a very interesting fact. There was a high flow of ecotourists in that part of Mongolia, and not only from Russia, but also from Mongolia, because there are a number of sacred sites here that local people love to visit. And you see here on the picture, there is a monument that is visited frequently by tourists, and we found the infected ferret and isolated 7 strains of plaque from this ferret and fleas that were on the dead body. The left picture shows another example. Near to highway Chusky, which is frequently used by Russian tourists and Mongolian tourists as well. So very close to the highway I've been talking about, there have been found a dead ferret that had two cultures of the plague microbe. So all those sites are frequently visited by people, and again, epidemiological risks are certainly very high. Overall, if we count all areas west, and we should understand that these strains are distributed throughout that Russian region very fast. So simultaneous circulations of virulent strain was at a high level. So we have registered 51 sites of plague outbreaks, 51 cases of plague outbreak. So, and here you see some information on what we do currently. Unfortunately, COVID restricted us from continuing our program, joint program, even though we do understand high importance of the project. This year, again, due to our solid experience of joint work, as we had on-time reports on each case that pointed to plague, possible plague risk, we were able to act, to respond appropriately. Overall, we had 19 suspicious cases of plague, and but we only in the Mongolian region. The next component is better readiness to fight the spread. We have provided trainings of Mongolian specialists. We, in particular, we conducted 2 72-hour seminars. We have prepared, and one of the seminars was held in Ulaanbaatar and included training of 21 specialists. Certainly, trainings are extremely important. We also did trainings at the sites. For 2 years, we held such trainings both in Russia and Mongolia. We would invite experts from the other country, either Russia or Mongolia. And in 2018, there had been conducted international training. The legend was an outbreak of plague that led to establishment of on-field hospital in order to prevent the spread of the disease. It brought together more than 200 specialists from various fields, including medical experts and so on. And their training showed that Mongolian colleagues are fully ready to counterpart this disease. And when, in fact, they had an outbreak on the border with Russia, when 2 people died, they followed the algorithms that we practiced during the international training. As for material and financial support, we on the regular basis, we provide diagnostic tools to our Mongolian colleagues, including testing kits, lab equipment, disinfection equipment. We provided a mobile laboratory. And in November 2020, despite the border was closed, we transferred, we provided Mongolian colleagues with this mobile lab complex, and they feel very thankful for that, because it really helps to optimize their work. In the near future, if there are no reasons to believe that situation is going to improve with the plague since the main focus of the medical community today is on COVID, and especially given the high density of ferret populations in this area, we have every reason to believe that there will be a number of outbreaks of plague in the next years. So we have to be fully ready in order to respond on time. Joint cooperation would be extremely important in future, and works on Russia and Mongolia shall be held simultaneously. We should remember that plague is an infection that doesn't allow to have any compromise with it. So surprises as we had in 2014, 15, and 16 shall be prevented in future. We work in accordance with the decree of the government of Russia, and the conclusions are quite similar to what I've been talking about. Certainly, epidemiological situation remains to be tense, both in Mongolia and Russia, especially on the border. In 2021, it shall not be improved. And I did not mention, due to the fact that we are limited in time, I forgot to mention one very important project. There was a small local, small area where we found similar strains of plague, and we had a few positive PCR tests. As for the Baikal region area where we took preventive measures, we did not find new strains. Well, and we have to act together to continue our joint cooperation in order to prevent the spread of this infection throughout Russia and Mongolia. Thank you very much for your attention. Thank you, Sergei, for your very relevant and very interesting report. Indeed, the aim to reduce risks of plague complications is extremely relevant both for Russia and Mongolia. And indeed, only joint actions, joint efforts will make it possible to fight the infection and reduce risks, as you have shown in your report. Well, thank you very much. Now I would like to give floor to our next speaker, Lilit Avetisyan, the Deputy General Director of the State Non-Commercial Organization of Control and Prophylaxis in the Republic of Armenia. She will be talking about actions on preventing plague in Armenia.
Thank you, distinguished colleagues. I would like to present my presentation. Global warming, natural disasters. Global warming, natural disasters, and international terrorism made us review our approach to epidemiological monitoring of focal diseases, including plague. 95% of Armenian territory is a focus of dangerous infectious diseases. Practical and epidemiological monitoring of natural territories of Armenia was started in the 40s. Today, we have epidemiological vigilance over these diseases. It is aimed at studying difficult phenomena that develop under specific natural and social conditions. To improve epidemiological and epizootic monitoring of plague, we researched the monitoring system. The materials for this research included reporting forms of the National Center for Control and Prevention of Diseases. This work actually was conducted, and we analyzed information from 1975 to 2019. We also analyzed the materials from the archive of the National Center for Disease Control and Prevention. The database was developed in Excel. To process the data, we also used ART software. And we also conducted expeditions, episodic examination, and mapping work. This was monitoring that was conducted in the whole territory of natural plague focus, and Anti-Plague Institute helped us to do so. 76 hectares were mapped, and these routes were mapped on the whole territory of the natural focus in Armenia Republic. Epidemiological and epizootic routes were mapped, and various methods were used, including night trap. On the basis of epizootic data, specific maps were developed. They were developed with GIS-10 use. And we also analyzed the habitats of voles in long-term stationary sites in Plesovenian plague focus during 3 years in 2 sites located in northwest and south of this focus. To record the coordinates of every habitat, GPS was used, and we also used laboratory methods such as molecular genetic, bacteriological, and serological ones. We also modeled the foci of plague in Armenia using computer software. In 2016-2018, in the basis of Rose-Nikchimi plague, Armenian epidemiologists and zoologists had professional development courses, and in these studies, 2 specialized mobile labs were used. They were used for express diagnostics, and they were provided and entered into operation in accordance with the administrative agreement dated 2016, concluded between Russian Research Anti-Plague Institute, Mikrob, and the Ministry of Healthcare of Armenia. In Armenia, on the territory, whose space is about 2.1 million hectares, 2 autonomous foci were specified. This is Transcaucasian Highland vole focus. These are Gyumri, Pre-Savanian, and Zangezur-Karabakh foci. And there is also Pre-Araxine gerbil focus. It is located in the north and northwestern part. So the north and northwestern part of this foci focus is located in Armenia, and part of the territory of both the foci and every mesofoci falls at the territories of neighboring countries. Today, these focused and potentially focused territories are outside episodic monitoring of our system. In pre-Araxine focus, the main carriers of plague include two types of gerbills and specific flea carriers, Anaphthalmus iranus and Xenophilum conformis. This agent is a gerbil strain, and in Transcaucasian highland focus, the main carrier of plague is a vole, and the main carriers are flea, Calopsilla caspia, and Nosopsilus consimilis. The agent is a specific vole strain. Bacteremia is established in 50% of infected voles. The duration and intensiveness are enough to infect, in both foci. There are accidental carriers of plague that also participate in this epizootia, but they do not play a significant role in maintaining this epizootic process. Epidemiological manifestations of plague in the territory of this focus have been registered since 1958. So 1958, 1969, and 1975, there were 3 such cases. In 2017-2018, epizootic study of Prisylvanian focus made it possible to catch a lot of rodents, and 1,600 flea and 7,000 mites were collected from the fur of these rodents. And among the samples gathered in 2017-2019 with the PCR method, 460 rodents have been studied. And we also studied 5,689 ectoparasite. There was 1 biosample, 6 nests, and the total number of molecular genetic tests, PCR, was 443. 166 rodents were studied with serological method, and the total number of serological studies was 180. The number of the main carriers of plague microbe, gerbil and vole, was low and middle. In Prisylvanian mesophoccus, that is 7.43 animals per hectare. And Zangizura Karabakh mesophoccus is a bit more dangerous. The number of voles was 41 animal per hectare, and in some territories it was up to 60 animals per hectare. The number of flea was from 100 to 200 animals per hectare, and the density of gerbils in Praxian focus was very low. It was not more than 2-3 animals per hectare. Epizootia of plague in Transcaucasian highland focus and pre-Erixene focus in transborder territories as well have not been registered. The last episode of plague was registered in 2008 in Zangizur Karabakh mesophoccus. In the territory of Gyumri, Prisylvan and Zangizur Karabakh mesophoci, these are transborder foci, the number of the main carriers of plague microbe is low and medium, and being guided by the data of epizootic monitoring, we can suppose that in good environmental conditions Only in some sectors of the focus where the density of the main carriers, episodic manifestations of plague are possible, and there are prerequisites for local epizootia. Transcaucasian highland natural focus of plague covers neighboring territories in the neighboring countries, and following the results of focus monitoring, we can suppose that in these territories, plague epizootia are not probable. However, some episodic manifestations are possible. These factors show that there is a need to improve episodic monitoring in natural foci in the following areas. It's necessary to select key territories of natural focus that can be a model of this process. To conduct detailed mapping, to extend the range of natural sites that are subject to laboratory plague investigation, to extend sequencing study using sequencer that was provided by Stavropol Research Institute to render methodological support to Armenia, and development of target measures in foci on the basis of the results of foci modeling. Monitoring component of the epidemiological vigilance is done by the National Center for Disease Control and Prevention. Epidemiological monitoring also includes episodic one. The territory of the Republic is divided into 300 sectors. 196 of them are subject to study. Field episodic monitoring in Armenia is conducted by specific groups and epidemiological teams prepared by 4 branches of the National Center, including the Laboratory of Epizooty, Actor Parasite Study and Reference of Lab Center, as well as Shibak and other branches. And in future, we're also planning to open a lab in Lovinsky branch. Apart from episodic study, in the case of epizootia, when the number of rodents and flea is excessive, urgent specific, non-specific preventive measures are conducted. Over the last 25 years, the equipment of Armenian anti-plague system has become outdated, so this equipment should be renewed in accordance with international standards. After the establishment of contemporary national center, the issue of new anti-plague station was in the agenda. To deploy this subdivision, we received a lot of support from the Russian Federation. So, Russia provided Armenia with a mobile set. This is a truck and specific equipment. Thank you. Thanks a lot, Lilit Mikhailovna, for your detailed presentation of the current situation in natural plague foci in Armenia Republic. Today, the situation is calm in Armenia, but still, we should always have epidemiological vigilance and monitoring over the natural foci of plague. And I'm happy to see that we have active cooperation among our profile institutions of the Russian Federation and Armenia Republic. This is a very important era, provision of epidemiological well-being in terms of plague. Thank you. And according to our agenda, we're going to have presentation of Nils Christian Stenseth from Oslo University from Norway. So, do we have connection? Yes. Nils is connected. Mr. Nils, the floor is yours.
Can you see my screen now? Can you see my screen?
Мы вас слышим и видим.
We can see you and we can hear you. Yes, we can hear you. Yes, and we can see the presentation.
Very good. Thank you very much for the invitation and the introduction. Dear colleagues, colleague scientists, ladies and gentlemen, I'm very happy to be invited, and I'm very happy to listen to the presentations that have been preceding me. I'm going to speak on the partly plague, but really what we can learn from previous plague pandemics in the current COVID-19. Something wrong here now? I don't get my cursor. Yeah, I don't get. Sorry. Yeah, here it is. I'm terribly sorry about the technical things. I'm a professor of ecology and evolution at the University of Oslo, and I'm the past and founding chair of Center for Ecological and Evolutionary Synthesis, where we have done a lot of zoonotic work, not the least on plague. I worked on plague for many years now, and plague, as you know, that is a disease of today, as we heard from Balakhonov, but also a disease that changed the history, human history. And as we have heard in previous presentation, the two previous presentations, this is indeed a disease of today. This is the WHO statistics where you have active plague outbreak and plague foci around the world. And as you also remember, there was a huge plague outbreak in Madagascar a few years back. I started working on plague some 20 years ago. It started in Kazakhstan, analyzing what I call a gold mine of data from the Soviet Union period, the monitoring data that you did all over the previous Soviet Union, where you had plague activities. Dry areas, higher altitude, etc. I then got involved, and I continue to be heavily involved in China, with plague work in China. As a matter of fact, we did a paper study on the border between China and Kazakhstan, where we studied the temporal variation in genotypes and the population sizes, both of the host population, the vector, and the evolution of the bacteria. Also been working in Mongolia, currently analyzing Mongolian data together with Chinese data on gerbils, on marmot, and also been interacting with Russia. I started off studying plague as an ecological system out in nature, out in wildlife. But I've, in the recent several years, also been interested in how nature and human population are interlinked. And a key focus in my work has been to study the effect of climate variation, which plays a very key role in the dynamics both in nature and regarding spillover to the human population. Indeed, natural catastrophes in the wild lead to catastrophes in the human population. Let me explain a little bit on that. You will have a local outbreak in the wildlife if the host population, say the great gerbil, stays above a certain threshold density for a couple of years over a large area. And if that is followed by a year of unfavorable condition for the host population, great gerbil, for instance, a dry year over a huge area, then the wildlife population, the gerbil population crashes, and that is when the bacterium spills over to domestic animal and the human population. That's why I say that when natural catastrophes happen in the wildlife, breakdown of the gerbil population, that can lead to spillover to the human population and then catastrophes like we have seen in the past 3 big pandemics, plague pandemics. We were fortunate to have a project here at the Center for Ecological and Evolutionary Synthesis focusing on ancient DNA. Actually start studying victims, human victims that for sure had died out of plague, study that from different places around the world in Eurasia, and then see how they link together phylogenetically. Because in 2015, we published a paper based on the Kazakh data that indicated that when there were favorable conditions in Kazakhstan or in Central Asia, favorable in the sense that you had some good years that the host population could build up, the gerbil population could build up to sufficiently high density, followed by unfavorable conditions so that it crashed, and you had spillover of plague to the human population. So we hypothesized in 2015 that Yersinia pestis, the plague bacterium, had been reintroduced, reinvaded to Europe many times during the medieval period. And here is what we found. In the beginning of the medieval period, that is immediately following the Black Death, the plague came in from northeastern part to Europe. And it probably came in connection with fur traders. This we don't really know, but it's a reasonable hypothesis. In fact, what is known as the land of darkness was sort of the source for the plague. So obviously there has been plague reservoir, which continues to exist, coming into Europe. But if you go later in the medieval period, go to the 1700s, and as you may remember, the last outbreak of the second pandemics in Europe was in Marseille, 1720. During that period, plague bacterium came into Europe several times, but now from the southeastern part, just outside Europe, from Turkey, from Caucasus, etc. So what can we learn from plague fighting over the years when it comes to the current pandemics we are experiencing, the COVID-19? Well, we can learn that hygiene is a key role to control a pandemic. And for plague, this is relevant in connection with human ectoparasite being a vector spreading the bacterium from one human being to another human being. So when hygiene was improved in Europe, that's most likely when plague disappeared and was never able to re-establish itself in Europe. Quarantine, you know, is very effective as avoiding transport across geographic borders. So this is sort of the wisdom that we can take out of the long experience of plague pandemics in the world. Let me now move to the COVID-19 pandemics. I'm running a project being paid out of the Norwegian Research Council, where we try to extract environmental data and try to predict how that affects the COVID-19 pandemics, so as to be better prepared for a future pandemic of a zoonotic disease, like plague, like COVID-19. I have a dream team of collaborators here from many places in the world, and I have fantastic advisory boards also from several places in the world. You might know some of the people there. We have done a couple of papers already. We published one in PNAS, Proceeding of National Academy of Science, a short while ago. And that paper shows that we could control much better the COVID-19 pandemics if the world, the international world, had been much more coordinated. By closing down the biggest airports in the biggest cities around the world for about a couple of months, then we would have had a reduction of COVID-19 incidents by 90%. We are having in second review, another paper now, that we really look at the more detailed structure of the epidemics. We look at the age composition in the country. Some countries have lots of old people. Some countries have lots of young, highly social, have huge social activity, social mobility. And what is the effect of that? Well, we study these kind of models. You don't have to look into that in detail, but this is to show you what I do for a living. Then to the left, we incorporate into this model the demography, the age structure of the population, as well as the social mixing pattern. And we parameterize this and then simulate the situation, so that it changes from the epidemic situation we are currently experiencing toward an epidemic situation that most probably will be a seasonal epidemic, just like we are experiencing flu. We studied 11 countries all over the globe: China, Japan, South Korea, Spain, UK, France, Germany, Italy, US, Brazil, and South Africa. And we could show that in South Africa, that country is hit harder. It is hit less hard. The epidemics is less severe than it otherwise would have been, because it don't have so many old people. It has much more young people. Whereas Italy are hit very, very seriously because it has a very old population. That paper is coming out in Science Advances in the near future. It's in the process of being accepted now. There are some few details. I will end by a few words about SARS and COVID-19. How the world responded to COVID-19 compared to how it responded to the SARS epidemics. The COVID-19, it was first discovered in China just before New Year, last year. Then it was sequenced in January and published internationally early February. And it was declared a pandemic in March. So WHO responded very fast and in very good cooperation with China. Compared to SARS, the responses were much slower. Whereas it took only a couple of months for the COVID-19 to realize it was going to be a global pandemic. For SARS, it took several months. It was first observed in November 2002, and it was declared a pandemic in March, April actually. So we are learning. May I end by talking about how science is very fragmented. This is really how science is operating. We walk along our trenches. We don't talk to each other. We don't read each other's papers. If we go to different conferences, if you go to the same conference, we go to different sessions. We don't interact. Science is very fragmented. Only the specialized fields are interacting. You need to pursue interdisciplinarity. Or we need to pursue interdisciplinarity and internationalization whenever appropriate for the scientific questions being asked. So this is how science should cooperate. We should work within each of the disciplines and come together and exchange wisdom and what we learn from each of the disciplines. Thank you very much for your attention.
Thanks a lot, Mr. Nils. Indeed, this information was very interesting. And I think that it was actually useful for everyone. And there is no doubt that the experience that has been received in fighting the pandemics and epidemics in the past should be analyzed and used in fighting epidemics and pandemics that we will face today.
Well, thank you very much. And now, let me pass the floor to our next speaker. Well, we have Institute from Iran. He will be talking about recurrent infections in eastern region of WHO. So, Mustafa, the floor is yours.
Уважаемые коллеги, у нас
Dear colleagues, unfortunately we have some technical flaws that do not make it possible to link us with the Pasteur Institute. Therefore, let me pass the floor to the next speaker. I would like to give floor to Avetisyan from the Republic of Kazakhstan. He will be talking on the importance of the hedgehog as a carrier of plague in the Pribalkharsky plague sites. Here, the floor is yours. Well, thank you very much, dear colleagues. First of all, I would like to say thank you to organizers for an opportunity to be part of this conference. And let me share with you the results of our pilot project that was carried out in 2016-2018. And the studies were made in a Pribalkharsky plague site. The study was carried out within the program Newton of Arabi. Well, a short background for those who do not know what plague is about. It's a very dangerous transmissible disease that is transmitted through fleas. They are carriers of the disease, and the Yersinia pestis is the agent, pathogen agent. It was discovered in 1894. According to WHO, every year witnesses about 2,083 cases of plague infection. Most of them accounts for African countries as well as Madagascar Island. On this slide, you can see the three latest pandemic of plague in 13th and 15th century, and 5th, 7th century, the first one, and the modern plague that took place in 1870s, and it was over in 1950s. We all know how drastically our life can change due to pandemic, but imagine what people had to undergo those times. We know that the Black Death took more than half of European lives. As for areas affected by plague, it has been found in most areas of the globe, apart from Australia. Most areas are located in Eurasia, also in North and South Americas, and even in such well-developed countries in the US, there are annual cases of plague with mortal outcomes, with death outcomes. As of today, there have been detected plague microbe in 351 types of mammals. Most of them are rodents, and 280 types of fleas are believed to be carriers of plague. In Kazakhstan, there are seven plague areas that account for 39 to 41% of the overall part of the country. The last plague case in human beings was detected in 2001 to 2003. there were detected 7 cases with 1 lethal outcome. Most of the plague areas most of the areas have the common transmitter, that is rodent, and 55 carriers and 51 fleas are believed to be transmitters. Thank you. On this slide, you see exotic area in Kazakhstan and classification of affected areas. In the west of the country, you see a violet area where the carrier is a ferret, then Gerby is believed to be the carrier, and most of the areas marked in green account for Gerbia is the main carrier. On this slide, you can see results of the monitoring carried out within 10 years. This data is a bit outdated. At the same time, they give us an idea of what's going on in the country. In green, we see areas that showed positive results, serological results. Red color marks areas with plaque microbe, and green and blue shows the areas that were covered by the study, by the monitoring. The most active areas are located in southeast area, also mountain part of the country, Big Poktalinsky, and other regions. There is a big question if we talk about plague understanding is to focus, to provide a proper focus of plague. Lots of specialists are trying to provide precise figures, and the current models fail to provide us with precise focused in order to understand when another outbreak shall be expected. At the same time, our Western colleagues in 2004-2014 published a number of trial results where they tried to focus new outbreaks of plague in Pribalkharsky area. This model is quite interesting as it employs main criteria such as a number of carriers, density of its population. At the same time, on practice, practice shows that this model is far from being perfect, and it gives lots of false positive results. At the same time, if you look at the scheme in the right lower corner, when there is a high amount of fleas and large density of rodents, unfortunately, the model fails to give a clear picture. That inspired us to do the following steps. We drew our attention to etiological aspects of carriers, their on-ground activities. In 2013-2013, we used GPS trackers for this type of animal. So this is an international group of scientists, including Australian colleagues, and so on. We also had our colleagues from Almaty Research Institute So within the study we performed, it turned out that as sandlands is a territory animal, so it lives at certain area which is protected by a male. And with high density of the population, the males prevent other types of animals into getting in the area, which prevents flea spread and therefore spread of infection. With a low density, level of subcontacts goes down and also prevents spread of fleas. For plague, it is favorable to have a medium level density. In such case, animals come to unpopulated areas and there they exchange with parasites that they bring to their own areas. We made a further step and started to think what shall be done in the in-between period. So when a carrier is not found in population for quite a long time, for example, plague can be witnessed within a few years, then there is a break for dozens of years, and then it breaks out again. So we were thinking how the plague microbe lives if there is such a great depression of the number of carriers. And therefore, we drew our attention to secondary carriers that to some extent also have contacts with areas, residence areas of sandlands. So why did we pay attention to them? During the Soviet time, from Soviet literature, we found lots of important information, in particular some patterns that the animals have a very high resistance to the pathogen. They have very high mobility, very high bacterial burden, and in places with outbreak, usually they witnessed a large population of such animals. Also, there is a theory that they don't have an individual area of living and they migrate from place to place. I mean in particular the type of animals you see on the slide. So why hedgehogs? Well, this hedgehog also live closely to sandlands. It's frequently seen in Central Asia deserts, despite very close contact to sandlands. There have been detected only one case of plaque microbe in this animal. In 2016-2018, during the project of evaluation of transportation of small animals as alternative carriers of plague, we paid more attention to the hedgehog populations. Overall, we caught 61 animals, 5 of them Mustela nivalis, and Vermilla perigusna, for Perigusna. So we used special devices that made it possible to catch the animals. The animals, after the catching, were placed into a cage for quarantine, and they were observed for a certain amount of time in order to find some signs of disease. After that, when we put on the tracking device of them, there was a requirement for the device to be equal to 5% of weight. Otherwise, animal could act inadequately if it was heavier than 5% of weight. So the animal was given a tracking device. We recorded all data on each animal, and after all, the animal was brought back to the area it had been caught and was released. All data on colonies of rodents, description of plants in the area was thoroughly studied and included into the report. We used Excel programs that helped us to do good, precise statistics. In order to have some quantitative data on flea dissemination, we studied a number of literature sources and we took some data as the basis of our study. So, how did we collect ectoparasites? As you see, with manipulation, doing some manipulations with animals, we used a bowl in order to prevent ectoparasites to escape. Then we would collect ectoparasites by aspirator and perform samples in lab. Previously, each unit was marked. Then, during the lab test, we calculated the index of parasite burden. So, how did we track the movement of the animals every day before sunset and before sundown until from 9 p.m. till 6 a.m.? Why did we do it at that time? Because that animals are active at night. We tracked each animal because each of it had a unique frequency. We used triangle method to track each animals, and when we had a visual contact with the animal, we tracked a meter tracked. A person tried to follow the animal in order to define the time the animal would spend in its house. We calculated the time and the number of visits into it. On this slide, you see white points. This is that shows colonies of sand lances. In order to find out how many colonies an animal could visit on its way of movement, we had to provide mapping of each point of residence for each animal. It was not a success every time, as it was difficult to track movement of each animal. Therefore, we modified the So here you can see a distance that is shown in red from A to B. So if the distance was long, it meant that most likely animal would stop somewhere else. Therefore, the radius of coverage of neighboring colonies would be bigger. If the animal was moving from A to B are the points where we recorded the time of our monitoring. So in the second case, if the distance between A and B was not big or the time was not long, the shape or the trajectory of moving was more complicated, as you see on the left part of the slide. So then we analyzed the data. What did we find out? The duration of contact with such points of residence. Well, first of all, we found out that there are two types of spending time, so long-term and short-term. During the day, an animal would stop at such point and would rest until the night. Here we see an average spending time. You see for hedgehog, the short-term stay is quite short, it's 3.1 minutes. And as for the night time, it's quite long, which is logical. Dissemination of flea per visit, what is that? Well, it's a percentage of fleas, and with the index of percentage of block of fleas, so that leaves the animal's body when it comes its residence unit. So together with the use of the literature and analysis of our data, we were able to calculate these figures. During the short-term visits, hedgehog lose more than 1% of their fleas, while other animals live many more. During the daytime when they rest, almost all fleas leave the body and new fleas gets on the body. As for average dissemination, on how many fleas are disseminated by an animal per day, as you see for the hedgehog, it's a very low rate, less than 1 flea, while for nivalis it's about 5 fleas per day, and for the ferret it's about 102 fleas. As for the average amount of points, the visit is about 0.8 for hedgehog and 2.9 for nivalis. We found out the intensity of contacts, but what if? How objective are these data for disseminators of plague? In order to prove this theory, we took data from archives in our republic, and we got the following figures. So the number of hedgehog was less 1 per gerbes, and it's even less for the second group of animals. Here you can see the size of home range. First one is the hedgehog auritis, perigusna, and nivalis. As for nivalis, for females, we unfortunately didn't get enough data. On average, for males of our hedgehog auritus, the size of the residence area is about 2.7 square kilometers, and for Perigusna, it's 4.2 square kilometers for males and 2.5 for females. As for the types of fleas that were found on the animals, again, mostly on this slide we show specific fleas of the gerbes, except for the flea typical for the hedgehog. As you see, if you talk about quantitative figures, the ferret has the highest parasite burden, and the hedgehog has higher burden than Gerbe. We do not know what are the reasons for that. It could be caused by the size of the animal or some other factors as well. As for the types of mites that we have found on animals, here there is another trend. For the hedgehog, it has the highest burden, microbial burden in terms of mites. On this slide, you can see the number of parasites on the studied animals. In red column, you see mites, and in blue, Fleas index. As for the parasite burden of fleas, so we see that ferrets' burden is much higher compared to gerbes and hedgehog. This curve shows data for the ferret, blue for the whistle, and red for the hedgehog. What is an individual area? It is a certain vessel that would be filled by animal movement at certain time. So we calculated accumulation of colonies visited by a certain animal, and then we calculated this trend, this pattern. You see that the whistle has different pattern of movement. As for conclusion, I would say the following. Given the data, we believe that the hedgehog cannot play a significant role in the flea dissemination and could not be a carrier of plague microbe, even though it could be engaged in the acute outbreaks. At the same time, this type has a limited area of residence that it does not live generally, which means that apart from the polecat, in comparison to a polecat that moves a lot, and therefore we can say that it does not have a high risk. But at the same time, given that hedgehogs showed a very high figures in mite parasite burden, we should pay more attention while studying these areas for mite parasites. Well, that's it. Thank you very much for your attention. Well, thank you very much, dear Aidanta, for this fantastic report. Indeed, studying mechanisms of the plague outbreaks and detection and discovering a new information on this disease will stay relevant for in the future. I would like to wish you success in your future work, dear colleagues. We have finished our program. If you have any questions to our speakers, if you would like to provide us with your feedback, we will be very pleased to pass you the floor. Well, as I see, nobody has any questions or comments, so let's conclude our session. Even though our topic sounds as food infections, today we have focused mainly on the most relevant issue, the plague. It was we have shown the relevance of this problem both globally and on the national level. Russia has been cooperated with a number of countries to eliminate the disease, in particular Kazakhstan, Armenia, Mongolia, and it goes without saying that plague outbreaks have no borders. It may happen anywhere, and a large number of outbreak areas points to the fact that we have to act together. We should, and only that will make it possible to provide successful prevention measure. First of all, in trans-border areas. I think this is the most important message of today's session that would be included in the resolution of the conference. Would you agree with that? Okay? In that case, thank you very much. Thank you. Our session is over.